a little bit about Ken Pugh. He's written several programming books, including the 2006 award-winning Pre-Factoring Interface-Oriented Design, and his latest book, Lean Agile Acceptance Test-Driven Development, Better Software Through Collaboration. So without further ado, Ken Pugh.
Thank you. So this is a talk about effectively communicating with acceptance tests. Thank you for the introduction. I just want to point out one thing here. In my introduction, I've been around for a while, by the way. I've done everything from gathering requirements to coding to final testing as part of my stuff. And here's my key phrase that both test-driven development and acceptance test-driven development deal with. No code goes in till the test goes on. No code goes in till the test goes on. So let me ask my developer friends here. You're coding away, right? You're typing away, you're coding. How do you know when to stop coding and turn it over to the tester? When you're tired, right? It compiles. Okay. Or maybe you've even been given a test for it. Okay. You shouldn't start coding until you have a test. That is my golden rule, which applies both to test-driven development and acceptance test-driven development. So here's my overall statement. There are exceptions to every statement except this one. And what do I mean by that? When I say you always ought to do something, I don't mean always, but usually always. And when I say never do something, I don't mean never, ever, but usually never. So if I say something and you go, that'll never work here, feel free to raise the exception, because we learn by exceptions as well as by the rules. So here's what we're going to talk about. A little introduction to acceptance test-driven development. Some examples of ATDD, the anatomy of a test, and then supplemental. It turns out I am flexible. I don't know how long 90 minutes is. It will be when I'm done. But for those who want an entire 90 minutes, if I finish my first part before that, then we will have a few more things to talk about. So first, the introduction. We're going to talk about the 5 W's and the H. My mother was an English teacher, so this is what she told me. So, what are acceptance tests? Who uses them? Who creates them? Or why use them? Who creates them? When are they created? Where are they used? And how to create them. So let's start off the first one. What are acceptance tests? They're from the external view of the system. Here we have this system. A user sends an input into the system. They get an output back out of the system. That's an acceptance test. Maybe if you're part of a larger interconnected system, you've got an enterprise database, or maybe you've got a third-party service provider. So an acceptance test can be, given the user sends an input into the system, we store something away on the database, or we send a message to a service provider. That's also an acceptance test. If we're doing ordering, we place an order. So the order goes from placed, and when they pay for it, to purchased, and when it actually gets shipped, to shipped. Any state that is visible to the outside world, and that change of state is an acceptance test. So let me give you some definitions that I use to keep everything consistent. We have acceptance criteria. Those are general ideas on how something will be accepted. Oh, those are the things you put on your user story. Acceptance criteria. The system must add two numbers together. Acceptance criteria, the sum must be correct. Yeah. Okay. Acceptance test. Given 2, when we add 2, we get 4. That is a test. Oh, what else could we get? Well, we could get 1, 1 or 1, 0 because we might be adding in base 3 or base 4. And having an acceptance test ensures that we at least understand that dimension. And then I have the triad. Who are the triad? The customer unit, the product owner, the business analyst, and anybody else, the developer unit, and the tester unit. So let me ask this. Does anybody want a fast car? Ah, good. Got somebody close. I was told not to go down so they can't see me anymore, so we can talk from here. You want a fast car? I'm going to develop you a fast car. Now, normally, this takes between 5 and 10 years, but we don't have that much time. So we're going to simulate. All right. 5 years later, here you are. We got your fast car. 0 to 60 in 14 seconds. What? It's faster than my car. Oh, did you want something different? 0 to 60 in what? Give me a test.
3 seconds.
3 seconds? How much money do you have? Oh, you're living on the West Coast with these expensive houses. Okay, you've got enough money. Okay, 3 seconds. 0 to 60 in 3 seconds. I wish you told me that before. Okay. I asked what you wanted a fast car. Oh, man. Okay, 5 years later, here we go. There you go. 0 to 60 in 3 seconds. Fast enough for you? Great, good, because 60 is its top speed. Yeah, I can see you are somewhat dissatisfied. Could you tell me what top speed? Give me a test for a top speed.
80 miles an hour.
80 miles an hour? Whew. Okay. I once had this, and it was one person, and they said, I only wanted to go 60. My teenage son is going to be driving it. Okay. Here we go. There you go. 0 to 60 in 3 seconds, top speed, 80 miles per hour. Fast enough for you?
Yes.
Great. You know, because we had to do a few modifications to get it to 80 miles an hour, we had to cut down the weight. And one of the things, the weight we had to cut down was the gas tank. So you'll be able to do 80 miles per hour for 1.2 seconds. Okay. So we could continue along like this. But what are we talking about here? We have a requirement that Timothy thought that I understood. We thought that we had agreement on the requirement, and obviously we did not. But what are those tests doing? They are clarifying the requirement. Okay. Now, we have acceptance criteria. We're going to run this on a closed course and measure the acceleration. All right. Stopwatch. Click. And we're going to click it when we get to 60 miles an hour. And if it comes out, man, in 3 seconds, then we have met Timothy's acceptance test. Okay, with the 80 miles per hour and everything else is the top speed. So there is our test. Our criteria is simply, we are going to do this sort of test. Oh, and by the way, is it okay? Does it have to be flat, or can I, like, run it down? No, okay. Actually, it turns out legally, or not legally, but if you're going to do any tests of speed, you have to do it in both directions within 1 hour. Why? Because the wind might change even within that hour, just in case you're ever testing a fast cars. So what do we have? ATDD as a prism. We take a requirement, and using tests, we understand that requirement. So a single requirement can get cut into multiple tests. So a fast car, acceleration, top speed, and anything else. Now, obviously, we're also going to have tests for how fast we're going to slow down, or whether we have slowed down at all. You didn't mention that, did you? Okay. So.
Well, you said it can only go fast for a short period of time. I figured there is drag.
So you figure if it does 80 miles per hour for 1.2 seconds, if you need to stop, you just rev it up to there, and then the engine will stop. Good thinking. Okay, we always have a bypass here. So now, why do we want to do acceptance test-driven development? Well, here are some solicited comments from some people for my book. Oh, and by the way, there is, and I can give the information later, my publisher has this one-day dealie on buying it electronic form, and I can give you that information at the end of the talk. So, why? Rework down from 60% to 20%. Means you thought you finished the requirement, it turned over, testers found something wrong with it, and it went back and fixed it again. Rework, if we cut it down from 60% to 20%, what does that do for productivity? Doubles it. We go from 40% new work to 80% new work. Jeff Sutherland, one of the co-creators of Scrum, actually did a true experiment. He added a QA person in acceptance test-driven development to a high-performing Scrum team, doubled their productivity. Okay. So it has been measured. Workflow is working the first time. Little room for miscommunication as to what we mean by fast. Obviously, we save time. My emphasis is getting the business rules right, because one of the toughest things is understanding all those business rules. In fact, I would suggest that at least 50% of code is business rule related. So it's game-changing. Tighter cross-functional team integration, because the entire team, from product owner, from business analyst to tester, all work together. Obviously, when we're past all the tests, we're done with the story. And finally, I break acceptance testing into two parts: writing the acceptance test and automating them. Writing them helps us understand the requirements and get them right. Automation for regression. Okay? But if you try and automate the wrong acceptance test, all you're doing is making your wrong product faster. So requirements and tests are absolutely interrelated together. A requirement needs a test to test that requirement, and a test should be against the requirement. So they go together. In addition, a failing test is a requirement. If you are not going to ship a system because a test is failing, it is a requirement that the system has not yet met. So testers, when you write a test, it is not a test. It is a requirement. And the passing test, the sum of all those tests is a specification on how the system works. Well, this concept of requirements and tests being two sides of the same thing, there's a little ditty that was written about it. In fact, it goes something like this: tests and requirements, how they go together. You can't have one without the other. This is why I'm still in software. So, in classical development, here's what do? We elicit requirements. And this is classical, even agile development. It's just the size of the requirement is slightly different. We elicit requirements. We analyze requirements. We design. We code. We test. And then we deploy. But we have loopbacks. Tests back to analyze requirements. Tests back to coding. Why do we have those loopbacks? What? Misunderstandings, miscommunication, miss everything. Okay, not Miss America, but okay. Miss requirements, miss other. So what do we want? Fast feedback. Feedback helps correct our misunderstanding. So we want quick feedback rather than slow feedback. The tests are going to be a form of feedback. A failing test says, I still have work to do. Okay? If you don't have fast feedback, this is what you wanted, and you may turn out to be that. You're far away. The faster we get the feedback, the closer we are going to be to what we want all of the time. So we want fast feedback. So what do we do? In acceptance test-driven development, we elicit our requirements. We analyze our requirements with tests. We write the test as we are analyzing the requirement. And we write all the tests before we start designing. And the developers get all the tests before they start coding. Okay, I know, this sounds strange. I don't know how you feel about the No Child Left Behind Act and all the testing, but if I have a teacher and the teacher says, your students must pass the test, what is the most logical thing for the teacher to do? Teach to the test. And if we give the developers all the tests that are going to be run on the system, what is the most logical thing for them to do? Code to the tests. Ah, there we go. So now, we have two different types of testing. Attempting to find defects is waste. Attempting to prevent them is essential. So let me go back to my developer friends here. So now, you're coding away. You got a compile error. Do you report that as a defect? No? You just fix it and go on, right? Okay, so you're missing a library. Do you report that or you just fix it and go on? So now, if we give you a test and the test fails, you just fix it? You're not going to put it into Jira or some defect tracking system?
No, but maybe we couldn't to see if that test is correct.
Okay, so we'll check the test correct. So now if we gave you every test that we're going to be run against your code, and you found a defect, you would just fix it, not put it in a defect tracking system, would you? Yeah. Oh man, and your testers? You're not going to have any defects to write up. Your job is over. Okay. Now this is where one of those always, always is not really always, always, okay? But the more tests that you create and give to the developers and assuming that they have the environment to run it in, the fewer defects that you have, the less that you have to triage to figure out which ones are the most important. That is the key. So in fact, do the defects occur? Yes, they do. We cannot prevent the defects from occurring. What we can do is detect them early before they escape. and prevention is just early detection. So, why do we do this? It's a cost of requirements. If we can, and these numbers may vary in your situation. 1 to 64, some people have reported 1 to 256. If we can find the requirement, misunderstanding at requirement time, that's a 1. Wait to implementation time, it goes up to a 4. Testing, 16. And if you have to worry about it in production, it's a 64. So everybody says, it takes time to write these tests. Well, you're going to write them sometime. And the sooner you can write the test, if we can do it at the requirement stage, we've started saving all of that effort down the line. So who does it? Well, the customer, business analyst, product owner, tester, and developer get together and they write the test. If we're going to automate the test, then the developer's going to do it. Okay, he's going to take the test and bind it. And who gets to run the test? Anybody, especially if we're using an acceptance test framework. So a test consists of writing, binding, and running. Now, there are 2 different terms that are used: acceptance test-driven development and behavior-driven development. And we also have TDD in there as well. So this is just a brief summary of their differences. ATDD, everything's written prior to implementation. We're going to be using a given when then, but the key is they are implementation independent. We don't care whether it's written in C#, .NET, or Visual Basic. It's still this, or even BASIC. It's still the same test. In test-driven development, we're going to take those tests and break them down into smaller tests that the developers can use to test their individual modules. In TDD, it's always automated because you're always just having one test pass, making it all work, add one more test, changing your code and making sure that all the previous tests work. So that's a slightly different process. Now, BDD, behavior-driven development, started out as a TDD framework, and they upgraded it. It's now a BDD. It's now for higher level testing. It gets associated with Cucumber, the Gherkin syntax languages, but it, in essence, is the same thing as ATDD. It's just a different name for the same thing. And there's finally one other thing called specification by example. And why do they call that? Because we've got business people. And business people say, I don't write tests. That's your responsibility as testers. Yeah, that's okay. I don't want you to write a test. I just want you to give me an example. And we're going to use the example as the test. Now, we're not going to tell you that. All we want is an example so we can understand what you've written. So in fact, let's get to an acceptance test example. All right. You are all, let's see, first of all, I need a developer over here. Oh, man, I've picked on you too much. Who else is in this row? Here's a developer. Anybody want to admit? Nobody else? Okay, did we have one developer over here? Oh, okay. Okay. I've got this simple little thing I want you to do. I want you to write a module that takes a temperature in Celsius and outputs it in Fahrenheit. Okay. Good. How many minutes is it going to take you? 240. 240 minutes. Whew. Okay. All right. The rest of you are all the customers. So what's your name? Michael. So if Michael's going to code this, he needs all the tests for it before he starts coding it. So input the temperature in Celsius, Output in Fahrenheit. Give me a test for Michael. Zero and 32. Negative 40 and negative 40. Oh, performance test, less than 2 seconds. Okay.
Don't do computations on letters or symbols.
Oh, A's gives an error. Anything else? Precision. Oh, so let's see. I input 1, 32.8. How many decimal digits? Who wants the precision? Okay, how many decimal digits?
32.
You want 32 decimal digits? Oh, man. Excuse me, this is going to be a while. Okay.
Minus 275.
Hold a second. Let me finish off this one first. All right. If it is 32 and it ends in a 5 in your 33rd position, do you round up or round down? Round up. Okay? So if this is a 0, this will become 32.1 at the end. Right? Okay, I just got one more question for you. If the answer is minus 32.05, you said round up?
I round down.
Hold it, did you want to round it up or round it down?
Sign dependent.
So does this go down to 0 or up to 1? And you expect Michael to answer this? You have to give the requirement. And we're asking you for an example.
Well, rounds down to 0 then.
Rounds down to, I thought you wanted it rounded up. Okay. Let's see. All right. So that's what you want, right? Okay. Whew. Got that, Michael? Now, do you think that's rounding up, rounding down, or both?
I think that's rounding up.
Ah, okay. Okay, I'm glad. You know, regardless of what it is, we don't have to worry about the words. We have an example that explains the words. Whew. And finally, okay, somebody else had another example here?
275 Celsius.
Minus 275?
Yes.
Is that below Kelvin?
Below absolute 0.
Below absolute 0.
I want an error out.
You want an error out. Okay. Whew. So it's because it's below Kelvin, 0 degrees Kelvin. All right, we have another. Oh, if we have a lower bound, do we have an upper bound?
I haven't found it yet.
There's one place, and everybody says, oh, so how about 1,000 degrees? That seems, yeah, 1,000 sounds great. Okay, so if it's above 1,000, then we're going to throw an error. Okay. What if you're what?
What if we're doing metallurgy?
Metallurgy. Okay, so then we have to go to 5,000.
Let's go to the double.
Oh, hold on a second. In fact, I was doing this one time, and one guy said, you know, I'm an astronomer. Okay, 5 or whatever, okay. Okay, or should we have an upper limit? So,
We got the obvious. Did we input hardware or software?
what?
Did we input hardware or software?
Software, right, that's true. Oh, man. Oh, that's right, we had a GUI for this. It's going to be human. Okay, so now we've got a computation. We have to throw out messages, or anything that is non-numeric. You have to do rounding up, rounding down, or whatever you call it. We have to count for errors. So, Michael, still 240 minutes?
So far,
Whoa! Oh, good job. Okay. I did this one time at one place. Developer said 2 weeks. All right. Celsius output in Fahrenheit. 2 weeks? He said, yeah, I've been around here a long time. So what are the other things that tests are going to do is go show you the scope of the story. All the little details that it's like, oh man, and then when the details come out and the customer starts complaining because you're increasing your estimate, it's like, oh, come on. Look at all the other things we had to do. All right. So what do we come up with? There. So what do we have? Oh, man, 32 decimal digits. I wish I had dynamic PowerPoint, okay, so I could just like type in the numbers and have these match up.
You want to be able to test the error, I have to type on the keyboard.
Yeah. Well, see, if we have 32 digits of precision, you know, I just picked the most normal one. Anyway, if we were going to do this, and now our developers are going to take these acceptance tests, one method, or are you going to break these down into multiple methods? Multiple methods. So we're going to take the acceptance tests and actually create tests out of them for each of the individual methods. Where do developers come up with unit tests? From acceptance tests. And now everything is coherent and cohesive. Let's take another example here. Here is a business rule. I have a customer whose rating is good and has an order total of $50.01. What discount should apply? One 1%. 5%. Ambiguous? He can't be ambiguous. I wrote it. No. Okay, I had to work at it. Is it 1% or 5%? So what happens here? The developer types it away, interprets it as 1%. Tester looks at it, goes, developer, it's wrong. It's supposed to be 5%. They get together and they go, 6%. And the company goes down the drain. Okay. So what do we need here? In order to be able to understand an ambiguous thing, we need an example. So, who's going to play the part of my business person down here? I know my product owner's too far in the back. Okay, you look like a good product owner. Okay, you've just given me this business rule. I just am going to come up to you and say, you know, that's a perfectly fine business rule. And it's not the way you wrote it. It's the fact that I took engineering in college, so I didn't have to take English. So I have some issue, you know, it's my reading of your business rule, not the way that you wrote it. So let me just ask an example here. That customer rating of good of $50.01, it's supposed to be 1%, right? Yeah, I'm helping you out for the speed. Okay, 1%, thank you. And I just, $10 in good, that's 0%, right? Okay. Anybody ever see the Detective Columbo? Okay. So that's all you do. You just walk away and they go, oh, excuse me, I just got one more question for you. Okay. The $50.01 excellent is 5%, right? Okay. So now we have our examples. Our examples because our business does not write tests. But what are these? Our tests. In fact, subtly, we do breakpoints and equivalence classes and everything else, but do not use those terms for the business. Okay? You simply create them and you pick the appropriate examples.
Who defines good and excellent?
What?
Who defines good and excellent?
Oh, that's a different test. But thank you for bringing that up. That is a different one. That's a different story. So we have the tests. What are we going to do with them? Well, there's 4 ways we can use these tests. A testing script, a program interface, an XUnit framework, or an ATD framework. So let's take a look at these. Oh, a testing script. You log on as a user who's good. You enter an order of $10.01. You complete the order and you check it out that it has a 10-cent discount. Great. We have just completed one of the tests. There's only 5 more to go. Carpal tunnel syndrome. Okay. Yep, we got to do it. This does not sound good. So here are another way we could do it. What we want to do is expose the business rule to the outside world. That is, somewhere inside our developer is going to have a discount method, and it's going to compute the discount. So maybe we'll do a discount percentage screen. Maybe we'll make it a command line. And now you can enter all 6 of the values, 6 lines, and check to make sure the discount is correct. Okay. If we do this, you can put it in a little script, loop through everything, and now you've checked the business rule. You still have to do this script once to make sure the business rule is connected together, but we shouldn't have to do all 6. Since we had our test, and we've gotten written before we write the code, the developer can make sure that that method or whatever's internal is exposed and is so that we could test it in this manner. The third way, an XUnit test, JUnit, NUnit, anything else. Is that readable to you? No. It's readable to developers, or maybe testers if you've written some code, but it's not readable to our business. Therefore, it is not a good test. It is an automated test, but not a good test. For those not into JUnit, basically we call compute discount on some object, we give it the dollars and the good, and it returns back and we're going to compare that back to 0. So let's do one more. Did you understand this test? Order rated, customer rating, discount percentage? Okay, great. It's a test. Did you see that? Now let me do it again. It's a test. We're going to run the test. There we go. Our discount percentage. We expected 1. It returned 5. We have a test failure. This is an acceptance test framework, understandable to the business, to the customer, and automatable. That's what we want to do. So we could have our requirement as a test, and we could have our our requirement as a table, and we could have our test as a table. This is our test as a table. I would really like our business to be able to write all the business rules as a table, but that will never happen. Okay? So, but everybody understands a test because tables are in the language of business. Business speaks Excel. Okay? And so we want the tests and the examples to be in their language. This happens to be the fit framework. With that, we can do it, and some people have heard of Cucumber. This is just an alternative way of doing it. Notice we still have the same table, and it's just got a few more words at the top. So now, before I take a test anatomy, is this our 3-minute break time? just a look at test anatomy. Here is a scenario. A scenario consists of three things: a setup, a trigger, and an assert, or given, when, then. So here's our initial system state. Our action or event occurs, and this is what we expect as our output system state. Give an example of the scenario. The car is not moving. We press the accelerator. And we should reach 60 miles per hour in 3 seconds. Okay. So what is a test? A test is given an initial system state, when an action or event occurs, then we are going to compare what we actually got to what we expected. So tests and scenarios are somewhat the same, with the addition we're going to check to make sure that 60 miles per hour was reached before 3 seconds on the clock. So that's our test and our scenario. Now here, in fact, is where the difference in the two terms of BDD and ATDD occur. Our expected system state and behavior in our scenario, output and state, is our behavior. Therefore, if the expected behavior drives development, we're talking about behavior-driven development. But we are going to write a test for that behavior, so we're going to test that the behavior is acceptable, and that becomes, if acceptance tests drive the development, then we have acceptance test-driven development. So one is simply BDD says this is the behavior we want, and acceptance tests concentrate on the fact that this is the acceptable test. This is the behavior, the test for the acceptable behavior. So let me give an example with workflow. Now, this is an example I use in my book and a couple other things. It's Sam's lawnmower repair and CD rental store. You may wonder how Sam got into the business. So let me just give you the brief explanation. It turns out Sam was running a lawnmower repair shop late in the last millennium. And he saw these people coming in with these circular things around their necks. Anybody remember them? Sony Discman. So you could listen to a CD. Okay, portably. I know, those who only have iPods, pads these days or whatever. Okay? But it was pretty cool. So he realized there was a business. People like to listen to music while mowing their lawns. So he opened up a CD rental store using index cards. He'd come out of the back. He'd wipe his hands off, the grease off. Somebody would rent the CD. He had an index. He'd just put down who rented it and pop it into a rented. Fast forward. People are no longer coming in with those circular things around their neck. But people are renting like 20 CDs at a time and bringing them back in 2 hours. He doesn't know what's going on. He's thinking, man, these people just can't figure out what music they want to listen to. But he's making a bundle, and now he needs a software system in order to be able to do this. So this happens to be one of our scenarios. Given our customer has an ID, and the CD has an ID, so those are two initial system states, and the CD is not currently rented. When the clerk checks out the CD, then we're going to record it as rented, and we're going to print out a rental contract. So given, when, then. That's a nice outline for a scenario. It is not a test because we don't have data in an absolute pass-fail mode. So let us add some data to this so we can make it a test. So given the customer has an ID, here we have customer James has an ID of 007. And the CD has an ID, Beatles' Greatest Hits of CD2. and the CD is not rented. So now we have set up our initial system state. How did we get there? From another test or scenario called register customer and inventory CD. Given all that stuff, when the clerk checks out a CD to 007 at CD2, then we record it as rented and a rental contract printed out. So now it is rented to 007 and we print out a rental contract. Okay. You were a product owner. You now are the product owner. Mr. Product Owner, let's see, Kevin, Mr. Kevin, product owner. Is there anything else? Did I capture most everything? Is there anything else you'd like to see, like on the rental contract? Oh, how much they owe. I'm glad we had this discussion before I just did this. Okay, so you want a payment. And would you like anything else on it? Like maybe the date it's due or something? I'll just give them, okay. All right, so they'll forget when it's due and you can make lots of money. Okay. I'm sorry, you did not do the right answers. Okay. At least for my non-dynamic PowerPoint. All right. So, due and fee. All right. So it turns out, you must have a business rule of how much you're going to charge them, right? Like $3? And, excuse me, that was for 2 days, right? That's okay. All right. I know you're new at this CD rental business. That's okay. All right. So we got business rules. So in fact, actually, what we can do is when we get down to this level of detail, we can discover missing business rules. All right? Because everything that appears on the output, on the then part, has to come from one of three places. Was it in the initial state? Was it part of the action? Or was it a business rule that somebody hasn't told us about? So now we're getting more complete requirements and details by coming up with a specific test. That when part, it's not specific. Could we put it into a GUI? Yes, we could use it as a manual test through a GUI. Could we call a method inside of our code and do this as an automatic test? We sure could. Could we use it as a test for an interactive voice response system? Please enter the customer ID followed by a pound sign. Boop, 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 boop. You entered 0707. If this is correct, press 1. If this is not correct, press 2. Doesn't matter how we enter it. Our test is not tied to our input mechanism. It's tied to the functionality that we are entering some data into the system. So you gave me that simple business rule. I heard you had a little more complex one. Okay, something like you actually have 3 categories for the CDs, regular golden oldies and hot stuff. Yeah, and here's that business rule you gave me. 2 days, $2 for 2 days plus $1 a day extra, or $2 for 4 days plus 50 cents and so forth, right? That's pretty straightforward. Okay, I like that. Okay, in fact, if you don't mind, I'm just going to put that into a table somewhere just so I can understand it better. Okay, so we have the base rental period and a base rental fee and an extra day rental fee. Okay, I'm just taking your stuff and just trying to make it a little more consistent. I thank you. That's what we programmers have to do, is read customers' minds. Okay. So I'm just going to try and look. It's pretty straightforward, but I just want to check my understanding. So a regular for $2 costs, or 2 days costs $2, right? And the golden oldie for 5 days costs $2.50. Okay. Hot stuff, 6 days, $12. Okay. Hot stuff for 50 days. That's going to be $100. Here is Jerry. Here is your best customer. He's been a loyal customer for 20 years. He just rented something. It got stuck at the bottom of his pile. He didn't bring it back for 50 days. You are going to charge Jerry $100 for a $20 CD? Would you put up with that, Jerry? No. You want to put up with that? So now you probably have to check with a few people to see exactly what we should do, right? Probably. So what would you say to me if I said, what the value should be, what the number should be? You'd probably say, I'll get back to you on that. Okay? Okay, you might have a different pronunciation. Yeah, whatever you like to say. What if we capture it? Guess what? If we put this in a business rule test, this will always fail. Okay? We will have failure not because the system doesn't work, because we have a requirement that has not yet been specified. Okay. So, that's the reason for it. And we can put that anywhere. But in getting back to one point, if we were waiting for this, can't we at least go ahead and develop all the rest of the stuff? This is where if developers go, I'm not going to touch anything to all the tests. There's a balance here. If you've got sufficient tests, developers should be able to pass those and then wait for the completion. So, almost every use case, every scenario always includes business rules. We can do complications. We can try and do scenarios for every possible business rule. But what we'd rather do is test every business rule independently for all the combinations and just make sure they're incorporated into the flow. Okay? And every flow test is going to obviously use one variation. So if we took the same thing and added in our type information, so we have our customer data with our type, and we have our one regular with a two-day base rental and a $2 base rental fee. When we check it out today to that person, then that is what we have. So now we're going to have a flow test that incorporates the business rule as well. And so we're testing both individual business rules and flow. So I've got a few guidelines here. You create an acceptance test. It is not throw over the wall. Okay, here, make it pass. It's a focal point for communication. When there's any questions, you go back to the test and you go, did I understand this right? Did I get the right value? Let us use the test as our focus, which is why tests need to be able to be read by the business, or else you can't communicate. They are always in business domain terms. There is nothing called a double. There is no ints. There are dollars. There are counts. There are percentages. All tests are in business domain terms because it's a communication with the business and the customer. I had one little tweet I made. I said, Acceptance tests start with communication, not automation. So what we want to do is make sure that we've got the right values, make sure that we understand the requirements. Take those then and automate them offline. Do not worry about automation during the process of collecting and understanding the requirements. But automate them. As much as practical, 100% of your requirements should be automated. Now, some people have guidelines for code. I'm one for requirements. If we have 100% of requirements automated, chances are you have 100% of your code. Or you have code that is just sitting there that doesn't do anything. Okay. 100%. And as I mentioned during the break, if turns out you have a story, and the story starts to have more and more acceptance tests to it, then you could break your story down. Take some acceptance tests and have a story that has some, and have a different story that has some more of them. Because if you are going to show delivery of business value, the passing of an acceptance test that's understood by the business is business value. You can show partial delivery. None of this, oh, we got the database working. You can't show that. That doesn't deliver anything. But if you can show you've been able to deliver something, even if you don't have all the business rules, the business rules can be separated out into separate stories. And now just a few other thoughts. And I'm told that about 5 o'clock we're going to start with a few questions here. These acceptance tests are not everything. They are only a small portion of the picture. Here is a test grid. It actually, well, it's been around for a while. It came from the Poppendix and Brian Merrick and everything originally. There's our functional test on this side. And there is our cross-functional test. I like the term cross-functional because if you say non-functional, then to a layperson goes, oh, so it doesn't have to function. Okay, that's a non-functional. So it's a cross-functional. So our acceptance test we're talking about is up in the upper left-hand corner. Those are the customer tests. If we automate them, they become an executable specification. Now we're going to take those tests, and where maybe an architect or maybe a designer is going to take that and break that into tests for components. That is, individual pieces that are going to all help to meet the customer test. And then we could take those tests and break them into smaller little pieces for the unit tests, for the individual pieces. Okay? So unit tests come from component tests, come from customer tests. For simple systems, you might even cut out the component, and unit tests just get directly from customer tests. These are necessary, but not sufficient. What's on the other half is our cross-functional tests. Oh, man, it needs to be performed well. Oh, less than 2 seconds. It needs to be secured. How do you test for security? You hire somebody to break in. Okay. So you've got your automated security test, but it's like the hackers know you're going to run those. Okay. It's like, okay. So you're never absolutely secure because you're always testing and things against you don't know. But we need to do that. We have usability testing. How do you know something's, oh, that's a beautiful requirement. The system must be easy to use. All right. How do we come up with tests for that? An objective test? Well, our objective test. We are going to turn this system over to 100 users of varying skill levels. And they are going to report back on a 1 to 5 number scale whether it's usable or not. And as long as the average is 4 or greater, it's usable. Okay? So let's come up with objective tests for that. That's not going to tell us what needs to be usable, but at least tell us whether it is usable or not. Okay? And then exploratory testing, which, since you're most testers here, you all understand. For the few developers, exploratory testing is taking paths through the system that are unexpected. I give the one example of exploratory test. Everybody's ordered something online, right? And you hit the button called place order. And the screen comes up that says, do not press the back button. The exploratory tester is going, yeah. Back, forward, back, forward, back, forward. Oh man, I got it free and my credit card didn't get charged. All right. Okay, who knows what happens? That's exploratory testing. So we have to do this, but it's insufficient. We need to do some of that as well in order to make sure our system is usable, secure, and works. The other thing is a context diagram, and I always emphasize this. A context diagram, what is in and out of the system, because acceptance tests are from the external view of the system. So we have to decide what is in and what is out. So here's our external actors. We've got some input and output, i.e., there's something's going on. Maybe we have some inputs from hardware devices or outputs to servers. So that's our context. We're going to, for example, here is the context of our automobile. Externally, 0 to 60. And we get movement, 60 miles per hour in 3 seconds. Oh, by the way, did you want it to go? That doesn't matter? No. Oh, okay, because we have different implementations that can produce the same behavior. This is a normal one with a gasoline engine. That's going to make. But it's for a Tesla, and the internal implementation is just electric, it's going to go. If you had a requirement for noise, then we would have had to add a noise generator. Okay. Actually, this is a real-life situation. Anybody drive a Prius? Okay, we got a few Prius drivers. You go into stealth mode, right? Okay. There's actually, so the stealth mode for non-Prius drivers is you're an electric between about 0 and 30 miles per hour, which means the engine makes no sound hardly. And they are actually, in some places, adding a noisemaker so that those who are visually impaired can actually hear the car. All right? So our customers are not just the drivers, but other people around. So, but the whole point is that acceptance tests are from the external point of view of the system. Timothy is not going to specify the transmission or the drive shaft. Those are component tests that the architect of the automobile is going to specify. Anytime, in fact, the reason for the context diagram is anytime we have an external system. Anybody go to the talk on mocking AWS? Okay. All right. Anytime we have an external system, we know we want to test double for it so that we can have repeatable tests. We want to mock time. We want to mock anything on the outside world. Okay? And the context diagram shows what it is. And we do want tests that cover the entire flow, all the way from the UI down to the persistence and service levels. So we are going to have one complete integration test all the way. But we can't test everything all the way. And so we might be able to break things up. to where we mock out or make test doubles for our persistence and any services. We test from the UI all the way down through our core business logic and test the services individually. Or we might break it up so the UI actually talks to a layer, a test double layer. We can apply the same acceptance test to all three of these things. In particular, we can do it for here to here, because since we are making up test doubles, we can construct the data we want for our test and the responses we want. It's a little bit harder to utilize the same acceptance test here unless you have the ability to actually create our customer James with 007. Some places you can do that. Other places, the enterprise database is sort of off limits for you. So here's our automation pyramid. The more we can automate, the higher we can keep our quality as we add additional functionality. Unit tests are the de facto standard for the developers, but business rule acceptance tests, and as I mentioned, I would say at least 50% of code or more is business rules. You order from Amazon. All you care about, you have the simplest possible acceptance test. I order a toothbrush. Does it show up in 2 days on my doorstep? You do all have Prime, don't you? Okay. All right. And it will now show up there on Sunday because the US Postal Service will deliver it. That's the simplest possible acceptance test. And I will give you a call if it doesn't work. But all those other business rules about how much is in stock and this and that and the whole works, those things need to be tested, but we don't want to have to run full flow tests for all of that. Those are our business rule acceptance tests. We can automate everything beneath the UI easily, and some of the UI we could automate, and some we're still going to be manual. So we could automate about 95% or more of our tests. Here's my last phrase. Avoid copy and paste. This applies to requirements. It applies to tests. It applies to code. Okay. So let me give you a little thought processes here. Back in the days when I learned typing, you were taught to keep your fingers on the home keys. Now, my instructor, this cannot be done anymore, I understand, used to have a ruler. And if you took your fingers off the home keys, the ruler would come down. And you learned to keep them on the home keys, which made it really difficult as soon as a mouse came out. Because I'd be typing away. It's really hard to move the mouse when you're keeping your hands on the home keys, let me tell you. Which is why I'm so glad that the ThinkPad has its oopsie daisy, its touch thingy on here. Okay. Voila, we've just broken everything. There we go. Okay. So avoid copy and paste. Put your fingers onto the home keys. Thank you. Oh, that's good. Okay. Now, start to hit Control-C. Excuse me, Control-V. Okay, Control-C. You've just hit Control-V. Now, I cannot hit you, okay? But just imagine the ruler is coming down on your hands, and as soon as you paste, it hits your hands. Every time you do a copy and paste, you introduce redundancy into your code, and into your requirements, and into your test. So that is my overall rule of thumb. So this is not an ending, but a beginning. What have we covered? The primary goals in ATDD. Discover ambiguous requirements and gaps in requirements early on. The tests represent a understanding, the common shared understanding between the business and development. Our secondary goals. We can always automate them, use them as regression tests. We can use them to measure the complexity of the requirements, because the more acceptance tests we have, the more complex the requirements are. And finally, if they are examples of how the system works, we can use them as our user documentation. Wow, we got a threefer in there. So, go forth and become acceptance test creators. Thank you. So now, any remaining questions?
Explain the difference again between EDD and ATDD. You said one was like driven by behavior, and the other one, I didn't quite get that difference.
BDD simply, the term behavior applies to our expected behavior, and the ATD emphasizes the test that it's going to test that expected behavior. So they're just two sides of the same thing. We always want to come up with two terms because that doubles the amount of books and consulting we can sell. Okay? That's. Anything else? All right, go drink tonight. The beer's the drinks on me. Thank you.